Hello and welcome back to GIT335 Computer Systems Technology. I again am your instructor Nicholas Lindquist, and today we are going to venture into Chapter 2, the Internet and the World Wide Web. We are going to explore cyberspace. All three of those terms you should be familiar with as we touched on them briefly in Chapter 1. The Internet and the Web. The Internet began in 1969 as ARPANET, and it was a civil defense project during wartime to protect our nation's vital information. It was stored in several different computers at several different universities at different places in the country all at one time, that God forbid if an attack should strike and level one particular part of our country, all of that vital information would not be lost since it would be housed in other places as well. The original incarnation of the Internet was text only, as you can well imagine, and then in the early 90s multimedia became available, and thus the World Wide Web was born. Actually, so you can see down here the first image uploaded to the web, but when you get down to it, that image is actually just a collection of characters that are a grid of pixels with zeros and ones describing the particular color in each one of those pictures. To connect to the Internet, you need an access device, a computer with a modem. And as we know, that comes in many forms. A smartphone qualifies, a desktop computer, or a laptop. 2, you need a means of connection, such as a phone line in the case of dial-up, a cable hookup, such as Ethernet coming from your cable modem at home, or wireless, some type of wireless adapter on your computer that will pluck that wireless internet out of the sky and input that information into your computer. And then finally, you need an internet access provider, such as Cox is a common one here, someone to actually connect that piping internet goodness through those phone lines, cable hookups, or whatever it may be into your computer. So these are different terms relating to the speed of the internet. Bandwidth, as you can see over here on this image, is best thought of as a pipe, and the amount of water or the amount of zeros and ones that can be sent through that pipe at one time, that is considered the bandwidth. Baseband refers to an older, slower type of connection that only allows one signal to be transmitted at a time. Maybe you've been down one of those old country roads where there's a bridge that's only wide enough for one car, and so traffic goes in one direction, and then at some point someone has to stop because traffic wants to go the other direction. That's how you can think of baseband. And then broadband are those high-speed, always-on connections such as we are so used to having in this modern era of fast and easy internet connections. Physical connection to internet, wired or wireless. The ancient archaic way of connecting to the internet is the telephone dial-up modem. So many people today don't actually even have telephone lines anymore into their houses. We just use our cell phone. But it used to be, back in the old days when I was a young pup, that you could either talk on your telephone or someone could use the internet, but you could not do both. As I said in the first lecture, should someone make the mistake of picking up the phone while someone else was using the internet, bad things would result. So nowadays we have always-on high-speed connections, such as DSL, which is still using through the phone line, or through a cable modem, which is slightly different. As you know, we have that coaxial cable that comes from the wall and can go to your television or to your cable modem. And your cable modem is the device that takes that cable signal from that coaxial cable and translates it into Ethernet form, which then goes to your wireless router, say, or directly hardline into your computer. And then wireless, as I said, a wireless router takes that internet goodness from the pipe, however it gets hardlined in there, and then puts it in the air like it just don't care. So data transmission speeds, we touched briefly on this, on something similar in the previous lecture, and it's important that I specify that these things are different. In the same way that, say, 10 miles is different from 10 miles per hour, the amount of data and the speed at which it is transmitted are different. So when we refer to gigabyte per second connections, that is different from a gigabyte of data. That's like saying a billion miles or a billion miles per second. Okay, so there is a difference. Should you see those questions pop up on the quiz, don't be surprised that you are going to have to understand that distinction. So then we say here, as these prefixes you will have to be familiar with. Bits per second would be 1 bit at a time. 8 bits, which as you know is a byte of data. A kilobit, kilo, is 1,000, mega, million, and giga, billion. Soon enough, I guess that would be a terabyte per second, and then we'd have whatever it is, exabyte. Anyway, that's probably another 10 years down the road. Uploading and downloading is when you take a file from your computer. Uploading is when you take a file from your computer, perhaps a very awesome photo that you just took, and you'd like to upload it to Instagram, say. So you take it from your smartphone and then you upload it to those servers at Instagram. On the other hand, let's say instead you want to download the PowerPoint file for this particular class, because I know you're going to be studying those PowerPoint files. You would log on to Blackboard, click on the file you want, and then it would come down instead from the Blackboard servers to your computer. So that's the difference, and make sure you do understand that distinction. Narrowband, and this is kind of computing history, is the only reason we're touching on this now. Again, through the telephone line. And then the reason, actually, that this is still somewhat relevant is that so many places these days we have that super steaming high-powered internet. But unfortunately, it's referred to as the last mile, in that the Ethernet, the high-quality cables that transmit that information very, very quickly, well, it's the lowest common denominator, in that the lowest point in the flow is the speed at which you get your internet. So it's going to take a long time for Cox and these other ISPs to correct the last mile of cable to each individual home. Is still going to be that old narrowband telephone line. So that's part of the reason that we have bottlenecks. Your internet speed isn't as fast as you think it should be because of that last mile of cable that still needs to be updated. Telephone modems, as I said, these things you'll be seeing these in museums soon enough, because nobody uses dial-up. If your grandmother uses dial-up, that's a shame. You should fix that for her. Nobody uses dial-up anymore. But as you may or may not remember, this is a dial-up modem card for the computer. It takes, as I said, modem means demodulator, which means it takes a modulated signal, which is analog, which you can think of an analog signal as a wave. Radio waves, for instance, anything broadcasted through the air comes in the form of an analog wave. And then it modulates it, and it becomes a digital signal that your computer can understand. Your computer cannot understand anything that's analog. Any analog signal will have to be demodulated for your computer to have any idea what it is that it is receiving. So that is the, telephone dial-up modem. Here, much more relevant, we have high-speed phone lines. So DSL actually sends the internet through the existing phone line system. T1 lines are still very expensive, but a lot of businesses have T1 lines, and that you need to send your information as quickly with as few bottlenecks as possible. And as it says here, the last mile can still be a problem. So even in the fastest T1 line, you are limited in the lowest common denominator in the flow of that signal, generally used by large organizations. Cable modem, as I said, I'm sure you guys still remember back when cable used to be a huge thing. Some people had regular old TV, which is 10 or 12 stations, which was still pretty awesome. But then other people had cable, and you could have Comedy Central, and then you could have MTV, and then you could have E, and these things were incredible, such luxuries to have. And now the internet is making even those things irrelevant. But the pre-existing cable modem takes that cable, that coaxial is what that cable's called, with that thin little needle on the inside, and it translates that into a binary format that your computer can make sense out of. Transforms it to Ethernet, if you look carefully, and then the Ethernet comes out of the cable modem and into your computer. Wi-Fi stands for wireless fidelity. And then so as you know, let's say your internet connection at home, you have Cox, which you have that cable modem, and your cable modem connects to your wireless router, and as I said before, the wireless router puts it up in the air. It's interesting in that if you think about, I've actually heard some people tell me before that the wireless is faster than the Ethernet, which simply cannot be the case, because there is no way that the wireless modem, or the wireless router, could possibly put it in the air any faster than it can receive it from the pipe. So that is why an Ethernet connection will always be faster than the wireless connection. If here on the ASU campus you have the opportunity to connect to Ethernet, you should do it. It will be faster than the Wi-Fi. There's no way Wi-Fi could ever be faster than the direct Ethernet connection. 3G uses the existing cell phone system. That's actually getting to be kind of an old standard. Instead, we have 4G, which is considerably faster than 3G. And these are technologies used by cell phones to get on the internet. Let's see, ISPs, internet service providers, as we say here, Comcast, AT&T, Verizon. Oh, those are wireless internet service providers. AT&T, T-Mobile, Verizon. We're all very, very, very familiar with these different companies, are we not? How does the internet work? Now this is interesting, nitty-gritty type of stuff. Let's really get into this because the internet is such a fascinating thing, completely changed our lives in every way. And what's even more interesting than that is thinking about where this technology is going. Anyway, continuing on, the internet, as I said, is a physical structure. It is a huge network that connects hundreds of thousands of smaller networks. When we talk about the internet, hypothetically, it would be possible for you to reach out and touch any part of the internet. So there are two different types of computers that connect to the internet. There are clients and servers. Whereas the client would be the computer that says, hey, what's up, Mr. Server? Could you please send me this particular Facebook page or this particular page on Amazon? And then that server would say, hey, what's up, buddy? Yeah, no problem. Let me send you that page. And this is made possible through TCP/IP. So basically, the internet itself is a whole bunch of computers that are connected through those internet, Ethernet, telephone, or other phone lines, and they've both made an agreement that I'm going to speak TCP if you're willing to listen to TCP. That way we can share information. So TCP is rather like the common language. Like if the entire world spoke English, TCP would be like the internet English. It's an agreement. You speak this language, I'll listen to this language, and we will have a great time serving the net together. The internet backbone, as I said, is there's, I believe, 7 is the number total of the thickest cables. I don't even think I could get my arms around the cables at the bottom of the ocean that connect our internet. But the internet backbone is those physical cables. As you can see here, there's a map of them, of some of them, crisscrossing our globe. Internet 2 is a new, faster version of internet. And I think very wisely, the people in charge of Internet 2 have allocated it specifically for educational and military purposes, unless you're willing to pay for it. So ASU does have access to Internet 2, but only parts of ASU use it. I'm sure the government, in their top secret and very, very interesting projects, only use Internet 2 because it's faster and better. Whereas if everybody else had access to Internet 2, we would probably use it for things that aren't as important, such as monitoring things on eBay and whatnot. And I'm going to assume that that's all you do on the internet is stuff that innocent. Anyway, moving on. Protocols, packets, and IP addresses. Now we're really starting to get into it. Handshaking and authentication. Handshaking is basically saying one computer says, here's the speed at which I'm going to send the information, and then the other computer says, okay, here is the speed at which I'm expecting to receive this information, is a digital handshake, and then in that way the information can be sent and received and understood. Authentication, well, we're used to authenticating, logging in with your username and password to authenticate yourself, say to ASU's server, so that you can access Blackboard, is authentication. Protocols, as we've talked about quite a bit already, TCP/IP is the fundamental internet protocol for sending and receiving of digital information on the internet. The smallest amount of data sent on the like one specific email would be a packet of information sent through the interwebs. So a packet consists of 2 parts. There is the header, which is the information about who sent it and where it's going. If you think about the analogy of an envelope, the header would be the stuff on the outside of the envelope, whereas the payload is the inside, the precious information on the inside. And when we talk about encrypted things being sent through the internet, well, you can encrypt your message such that if the receiver does not have the key, he or she will not be able to understand what is being sent in that packet of information. IP addresses are different per se than social security numbers, for instance, and that IP addresses can change all the time, whereas a person's social security number never changes throughout their life. Every time a computer connects to the internet, if it's using DHCP, it's assigned a new internet IP address. And that's a good thing because then it makes it more difficult to find those computers on the network should anyone have any nefarious purposes planned. Having a different IP address assigned every time is good because it makes you less predictable. Oh, here we are. Actually, it talks about this stuff here. So a dynamic IP address changes, whereas a static IP does not ever change. DHCP is the process that provides those new and different IP addresses every time the computer connects and disconnects. So this is something that I find interesting in that you might have asked yourself, or maybe not, depending on how much of a nerd you are, you might have asked yourself why the number 255 is so prevalent in things like default gateway, subnet masks, and IP addresses. The number 255, and also in RAM chips, it's also a standard of memory that you will find 256 megabytes of RAM, 512, 1024. Why exactly is that number so common? And that is because, as we said, a byte is 8 characters, and there are 256 different combinations of zeros and ones in 8 characters. So there's 4 zeros, 4 ones, and then there's 254 other different combinations of zeros and ones. And that is why the number 256 is so key. The World Wide Web. The face of the web, browsers, websites, and web pages. So as we said here, and we've already harped on, the web and the internet are not the same thing. The internet is physical. The internet is the infrastructure that supports the World Wide Web. A browser is a software program that interprets that information that it receives from those servers. And not every browser works the exact same way. As you can see here, there are different examples. Internet Explorer, Mozilla Firefox, Safari, Chrome, Bing, Opera. The first browser of all time was Mosaic, is the name of that, which may or may not pop up as a quiz question. So different browsers, because they're each different software programs, interpret that information differently. And that's why if you're having trouble, perhaps, say, if Blackboard is acting a little bit persnickety in a certain way and you're not able to download something, try it on a different browser. And more often than not, you will find that that just particular browser might be having trouble with that particular piece of code. So it's good to have, I have 3 at least browsers on each of my computers, and different ones are good for different things. So don't be unibrowser. Nobody likes a unibrowse. All right, that's good. I like that. Okay, a website is a particular location, a particular URL, such as we see here, www.worldwideweb.barnesandnoble.com is the example. And a web page is the different digital files found that populate that website. So if you were to actually go to barnesandnoble.com and view the page source of what you find there, you would see that barnesandnoble.com is actually an index file, index.html, and a whole bunch of other web pages in that same folder. And index.html calls in all those other elements, all that text, and then your browser displays that information in a way that makes sense to you. But at its core, and I'll actually demonstrate this for you right now. At its core, the internet is a bunch of zeros and ones. It's a bunch of text files. As I said, even images are basically, they're made up of characters. Everything on the internet is a 0 and 1. So let's go to ebay.com. And so here on ebay.com, should it ever choose to load? Ah, okay, here we have some images that are loading, we have some hot links, we have some very attractive graphics. This is what we expect to see when we log on. However, if we come up here to view page source. So here's what ebay.com really is, and how clever. Look, they've actually included this cool little text-based eBay image here. So let's make this full screen. Oops. So here's what's really going on. And all of the pages that you find on the internet are similar. All of these different elements are actually made up of text files. So this is what would be called as index.html at eBay. And as you can see, there's a table here, and inside of that table of information, you find a hot link. And this is when it clicks, it takes you to ebay.com motorcycles. And then here's another href, horizontal reference to a different place. There's all sorts of different elements, and as you can see, so these are other different pages. So there would be a motorcycles.html or motors.html. And so these are all different files linked together by the code inside of this one particular file. So that's just a very, very small peek at what a website really is. Don't be fooled. What we actually see is a very, very pretty outer shell, but what's going on behind the scenes is very, very interesting if you like to get into that type of stuff. And as I think I've already mentioned, a URL is short for Uniform Resource Locator. And it's an address to find a particular piece of information on the internet. So here we have, breaking down a little bit, what the HTML, or what the different parts of the URL. The protocol is HTTP, and as we said before, that's Hypertext Transfer Protocol, and that's one of the technologies that makes the internet work. It tells the client and the server the way that the information is going to be sent back and forth between them and how it should be displayed. So interestingly enough, if you are ever wondered about the difference between HTTP and sometimes you see HTTPS, that S means secure, in that it is encrypted and it's safe to send that information, that page. It's safe to submit that page because it is encrypted, whereas you would not want to submit banking information or anything terribly private on a regular HTTP page. Moving on, the domain name will be in the World Wide Web format, and that's why you always need http.www, whatever it may be, ebay.com, for where we just were. And then a directory or file, so inside of that whatever YOSI file, you will find an HTML document, and as I said, index.html would be one example of that. It tells the web page, your browser, that individual piece of software that you're running, how to display all those different elements found inside of that folder. Moving on, we've touched on TCP/IP before, we've touched on HTTP, and we have even touched on HTML. HTML stands for Hypertext Markup Language, and this is the technology that makes all of those different pages that constitute the internet link to each other. That is known as an HTML tag. Excuse me. So as I said earlier, we had the href, a horizontal reference. That is a link tag using HTML to another document that says when the user clicks here, go to this other document instead. So that's what makes the internet, there's so many things that make the internet work, but that's what gives the internet its connectedness from one document to the other, and you can surf all over the place thanks to those links that you can click on, and those are thanks to HTML. Just a little bit about email. There's of course different standards and specifications for the sending and receiving of email. Outgoing mail follows the SMTP, Simple Mail Transfer Protocol server that's run by your internet service provider. So perhaps you have tried to configure receiving email on your cell phone. In order to configure the sending of email, you have to specify the format in which you want it to be sent, which is almost always SMTP. And then on the other hand, you also must specify the way that your email will be received, which is the way that the server will be sending you the email, which in this case is POP3, or the example that's made here. And POP is such a cute little term because it stands for Post Office Protocol. So cute. So outgoing is SMTP, and incoming is POP, is one form that can be used, the example given here. So the difference between an email program and web-based email, I thought this was worth mentioning, and that a software program on your computer that manages your email would be like Apple Mail or Microsoft Outlook, whereas web-based email would be when you log on to hotmail.com, gmail.com, microsoftlive.com, anything like that. So if it's a built-in application that is installed on your computer, it is an email program. If you are going to a different website, or going to a website to send and retrieve your email, it is web-based. Here's the format of an email address, your username. So as you're very familiar, I'm sure, no doubt, my email address is nickl, N-I-C-K-L is my username, @ and then the domain name, the top level domain, which for me would be ASU dot, oh, I'm sorry, that would be the domain, and then the top level domain would be edu. So ASU is the domain, and then the top level domain would be .edu. Such as .com is also another top level domain. Email attachments. I'm sure we've all become very familiar with the need to be sure of email attachments before you open them. That's why it's important to run antivirus software, for instance. But it's important to know the person who is sending you and to know that it's not mischievous. If you don't recognize the sender, don't ever open the email attachment, because almost certainly no one is going to send you anything of worth if you don't actually know them. And also, as it says, if you personally have Microsoft Excel installed on your computer, it will create a .xlx file, for instance. But if you send that to someone who does not have Microsoft Excel, their computer's not going to have any idea what to do with it, because it doesn't have Microsoft Excel installed to say, hey, I recognize that format, I can open it, what do you want to do with it? And then finally, we have FTP, which is short for File Transfer Protocol, which is one-way technology for transferring files from one place to another. I use FTP quite a bit to upload files directly from my computer to general.asu.edu, which would be where I would upload them to the server at ASU where they can be accessed online. So FTP is File Transfer Protocol, and it's for sending files from one place to another very quickly and directly. SFTP is very similar, and should you ever have the choice, you should choose SFTP, because as I said before, that extra S stands for secure, and that means it is encrypted. Well, thank you very much for joining me for the second lecture and installment of GIT335. It's been a pleasure discoursing with you today, and I will see you all online.